electric charge is a scalar quantity whose SI unit is coulomb. The magnetic field lines passing through a closed surface is zero because all the lines which enter the surface, all of them will come out. Considering the initial direction of projection, that is what is called impact parameter. Hello students, this is your SD sir from the Temple of Excellence, Vidhyaashram, Pre-University, Mysuru. So true to its name, the Temple of Excellence. The thought to succeed always starts with the quench to compete. New examination pattern, new question paper pattern. What has SD sir in store for y'all? Yes, the solutions for the model question paper released by your PU board. SD sir will help the students to answer that with quench, with fastness and with intelligence. This is the blueprint of the model question paper. In the annual examination, the original question paper will compose of the same weightage. 1 or 2 marks here and there may vary, but the composition and the structure of the question paper will remain the same. Therefore, if you are thorough with what is the weightage given to each chapter, then answering becomes skillful. ನೀವು ಯಾವಾಗಲೂ ಎಲ್ಲಿ ಎಡುತ್ತೀರಾ? Numericals ಅಲ್ಲಿ. See, which are the chapters comprising here with numericals? No numericals with magnetism and matter. Numericals from electromagnetic induction, very rare to appear. No numericals from electromagnetic waves, from semiconductor electronics. Andre, out of 7 numericals asked, ಎಷ್ಟು solve ಮಾಡಬೇಕು? 3. Which will be the chapters of my strength? Electric current, alternating current, optics. ಇಷ್ಟನ್ನು ನೋಡ್ಕೊಂಡ್ರೆ I can very much ensure you out of 7, 3 problems very much easily you can solve in the exam. So have your confidence level on electric current, on alternating current and on optics. Reservely, yes, my Cadbury's chapter, you remember? Atoms. Yes. Chapters like electric charges and fields, you can keep both of them as reserve. So, if you understand the composition of the question paper, the structure and the mode in which the question paper is framed, it is very, very easy to answer the exam because half of the question paper will be on options. ಈ ಸತಿ ಎಕ್ಸಾಮ್ ನಿಮ್ಮ ಚಾಯ್ಸ್. ನಿಮ್ಮ ಸ್ಟ್ರೆಂತ್ ಏನಿದೆ, ನಿಮ್ಮ ಕಾನ್ಫಿಡೆನ್ಸ್ ಏನಿದೆ, ಯು ಕ್ಯಾನ್ ಸ್ಟ್ರೈಟ್ಲಿ ಆನ್ಸರ್ ವಿತ್ ದಟ್. ಓಕೆ, ಗೋಯಿಂಗ್ ಟು ದಿ ಕ್ವೆಶ್ಚನ್ ಪೇಪರ್, ವಾಟ್ ಐ ವಾಂಟ್ ಯು ಆಲ್ ಟು ರಿಯಲೈಸ್ ಹಿಯರ್ ಈಸ್ 2 points. Answers without relevant diagram and circuit wherever necessary will not carry any marks. Very important. 5-mark derivations while solving the numericals, especially while answering optics, ray diagrams. If you answer without writing the diagram, without writing the figure, without establishing the circuit, no marks is awarded for such answers. Because without these diagrams, without the figure, without the circuit, it doesn't make any sense. And direct answer to numerical problems without writing the relevant formula. Formula ನೆನಪಲ್ಲಿರ್ಬೋದು. ಡೈರೆಕ್ಟ್ ಆಗಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡಿರ್ತೀನಿ, ಡೈರೆಕ್ಟ್ ಆಗಿ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡ್ತೀನಿ, ಮಾರ್ಕ್ಸ್ ಕೊಡೋದಿಲ್ಲ. ವೈ? The relevant formula has to be shown. The formula has to be written. Then substitution, then calculation. And most importantly, ಇದನ್ನೆಲ್ಲ ಮಾಡಿರ್ತೀರಾ, ನೀಟಾಗಿ ಆನ್ಸರ್ ಅರೈವ್ ಮಾಡಿರ್ತೀರಾ, SI ಯೂನಿಟೇ ಬರ್ದಿರಲ್ಲ, 1 mark is deducted. So keep these points in mind. If you write any answer without the relevant diagram, without the relevant circuit, without the optical diagram, ray directions ತೋರಿಸಿರಲ್ಲ, there you lose marks. And any numerical problem solved without writing the formula and missing out on SI units becomes very costly in the exam. Now, going to the question paper, part A, again, the criterion for success, where you can score a centum or a 99, as I always say, is defined through this part A. So, we have to be clinical. Again, you are at the best. Why? Previous syllabus, I had 10 questions to answer and all 10 had to be written. 1 markers, 1 word, 1 statement, no stories. Here, I have 15 questions, out of which I can liberally select only 10. Advantage ಆಯ್ತಲ್ವಾ? ಮೊದಲು 10 ಕ್ವೆಶ್ಚನ್ಗಳನ್ನು ಕೊಟ್ಟು 10 ಉತ್ತರಿಸಬೇಕಾಗಿತ್ತು. ಸೊ ಲಿಮಿಟೇಷನ್ಸ್ ಇತ್ತು, ಅಲ್ಲಿ ನಿಮ್ಮ ಸ್ಟ್ರೆಂತ್ ಬರ್ತಿರ್ಲಿಲ್ಲ, ಕಾನ್ಫಿಡೆನ್ಸ್ ಇರ್ತಿರ್ಲಿಲ್ಲ. ಈಗ 15 ಪ್ರಶ್ನೆ ಕೊಟ್ಟಿರ್ತಾರೆ, 10 ಆರಿಸ್ಕೋಬಹುದು. ನೀವು ಯಾವ ಕ್ವೆಶ್ಚನ್ಗಳಲ್ಲಿ, ಯಾವ ಕಾನ್ಸೆಪ್ಟ್ಗಳಲ್ಲಿ ಕಾನ್ಫಿಡೆಂಟ್ ಆಗಿರ್ತೀರಾ, ಅದನ್ನ ನೀವು ಇಲ್ಲಿ ಬರಿಬಹುದಾಗಿದೆ. What will be the nature of questions? How questions are framed when it comes to 1 markers? Very simple. It may be the statement of any law defined in the syllabus. Gauss law ಆಗಿರಬಹುದು, Coulomb's law ಆಗಿರಬಹುದು, Ohm's law ಓದಿರ್ತೀರಾ, Curie's law ಅಂತ ಓದಿರ್ತೀರಾ, ಇನ್ಯಾವ್ದು ಓದಿದ್ದೀರಾ ಮಕ್ಕಳ? Faraday's laws ಓದಿರ್ತೀರಾ, ಗುಡ್, Lorentz law ಓದಿರ್ತೀರಾ. So certainly, as you can also see here, 1 question will be directly asked from this statement of a law. Next, there are certain physical quantities for which I can ask the SI unit. For example, as you can see here, I can ask the SI unit for resistivity. I can ask the SI unit for torque. I can ask the SI unit for inductance. So, statement of any law can be asked. Similarly, I can ask the SI units. Then, applications. Electromagnetic waves ಅಂತ ಒಂದು ಚಾಪ್ಟರ್ ಇದೆ. ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ರೇಡಿಯೇಷನ್ಸ್ ಬಗ್ಗೆ ಓದಿರ್ತೀರಾ. UV rays to application ಕೇಳ್ಬೋದು, IR rays to application ಕೇಳ್ಬೋದು. And certainly 1 will be or 2 will be applicative level questions. So if you bifurcate the syllabus in this manner and you study, answering 1 mark questions become very, very easy. So now here I am showcasing the questions from the question paper. And now I shall teach you all how to solve the 1 mark sessions, part A of the question paper. So part A, students, where you have to answer in simple words or statements, no essay type solutions, and you have to be skillful enough to bisect the question here. There will be 15 questions given and you can say answer any 10 of the following questions. So I have the liberty to optionate 5 questions here. So ಇಲ್ಲಿ ಉತ್ತರಗಳನ್ನ ಪಡ್ಕೊಳ್ಳೋದಕ್ಕೆ ಶುರು ಮಾಡೋಣ. The first one, write the physical quantity. He is asking us to write the physical quantity whose SI unit is coulomb. And I know all my kids will answer this question with closed eyes. ಯಾವ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟಿದು SI ಯೂನಿಟ್ ಅನ್ನ ಕೂಲಂಬ್ ಅಂತ ಕರಿತೀವಿ? ಗುಡ್. ಅಂಡ್ ದಿ ಆನ್ಸರ್ ಈಸ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಚಾರ್ಜ್. ಪ್ರಾಪರ್ಟೀಸ್ ಆಫ್ ಚಾರ್ಜಸ್ ಅಲ್ಲಿ ಓದಿರ್ತೀರಲ್ವಾ, ಅಲ್ಲಿ ಹೇಳ್ಕೊಟ್ಟಿರ್ತಾರೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಚಾರ್ಜ್ ಈಸ್ a scalar quantity whose SI unit is coulomb. ಅಲ್ವಾ? ಎಲೆಕ್ಟ್ರಿಕ್ ಚಾರ್ಜ್ ಈಸ್ ಅ ಸ್ಕೇಲಾರ್. ಮತ್ತೆ ಅದರ SI ಯೂನಿಟ್ ಅನ್ನು ಯಾವುದ್ರಲ್ಲಿ ಅಳಿತೀವಿ? ಕೂಲಂಬ್. ಸೊ ವಾಟ್ ಈಸ್ ದಿ ಆನ್ಸರ್ ಹಿಯರ್? ದಿ SI ಯೂನಿಟ್ ಫಾರ್ ರೆಪ್ರೆಸೆಂಟಿಂಗ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಚಾರ್ಜ್ is coulomb. I want to make a perspective clear here. Most of the times for 2 marks or 3 marks, they ask you all to write the fundamental properties of electric charge. Basic properties of charge. ಗಮನಿಸಿ, ಅಲ್ಲಿ ದಯವಿಟ್ಟು ನೀವು ಬರಿಬೇಕಾಗಿರೋ ಉತ್ತರ charges are additive in nature, charges are quantized in nature, charges are conservative. ಕೆಲವೊಂದ್ಸರಿ ಮೌಲ್ಯಮಾಪನ ಮಾಡಬೇಕಾದ್ರೆ ನೋಡಿರ್ತೀವಿ, ಪ್ರಾಪರ್ಟೀಸ್ ಏನ್ ಬರ್ದಿರ್ತೀರಾ? ಚಾರ್ಜಸ್ ಆರ್ ಸ್ಕೇಲಾರ್ ಕ್ವಾಂಟಿಟೀಸ್, ಚಾರ್ಜಸ್ ರಿಸೈಡ್ ಓನ್ಲಿ ಆನ್ ದಿ ಔಟರ್ ಸರ್ಫೇಸ್, ದಿ SI unit of charge is a coulomb. Yes, but when we ask for fundamental properties, make sure that you write charges are quantized, charges are conserved, and charges are conservative. So ಮೊದಲನೇ ಪ್ರಶ್ನೆಗೆ ಇಲ್ಲೇನು ಉತ್ತರ? ದಿ physical quantity which can be represented through an SI unit called coulomb is nothing but electric charge. ಎರಡನೇ ಪ್ರಶ್ನೆಗೆ ಹೋಗೋಣ. Define linear density of charges. ನೆನಪಿದೆಯಾ? ಸರ್ಫೇಸ್ ಡೆನ್ಸಿಟಿ ಆಫ್ ಚಾರ್ಜಸ್ ಓದ್ತೀರಾ, ಲೀನಿಯರ್ ಡೆನ್ಸಿಟಿ ಆಫ್ ಚಾರ್ಜಸ್ ಓದ್ತೀರಾ, ವಾಲ್ಯೂಮ್ ಡೆನ್ಸಿಟಿ ಆಫ್ ಚಾರ್ಜಸ್ ಓದ್ತೀರಾ. ಹಾಗಿದ್ಮೇಲೆ ಲೀನಿಯರ್ ಚಾರ್ಜ್ ಡೆನ್ಸಿಟಿ ಅಂದ್ರೆ ಏನು? ವೆರಿ ಸಿಂಪಲ್. ಐ ವಿಲ್ ಕನ್ಸಿಡರ್ a straight conductor, a straight wire which is carrying charges of certain length. ಒಂದು ಸ್ಟ್ರೇಟ್ ವೈರ್ ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀನಿ. ಸ್ಟ್ರೇಟ್ ಕಂಡಕ್ಟರ್ ಕ್ಯಾರಿಂಗ್ ಚಾರ್ಜಸ್ and of certain length. Now follow very carefully. I will consider 1 centimeter length of this wire. ಎಷ್ಟು ಲೆಂತ್? 1 centimeter length, ಯೂನಿಟ್ ಲೆಂತ್ ಅಂತ ಕರಿತೀವಿ. The number of charges present around this unit length is what we call as linear charge density. ಏನು ಹೈಪರ್ ಥಾಟ್ಸ್ ಇಲ್ಲ. ಒಂದು ಸ್ಟ್ರೇಟ್ ವೈರ್ ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಳ್ಳೋದು, ಚಾರ್ಜ್ಡ್ ವೈರ್ ಅನ್ನ, ಅದಕ್ಕೊಂದು ಸರ್ಟನ್ ಲೆಂತ್ ಇರುತ್ತೆ. ಆದ್ರೆ ನಾನು ಎಷ್ಟು ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಳ್ತೀನಿ? ಎಲ್ಲೋ ಒಂದ್ ಕಡೆ ಯೂನಿಟ್ ಲೆಂತ್ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀನಿ. And the number of charges present around that unit length is what we call linear charge density. So it is represented by lambda, and therefore I write lambda is Q divided by L, number of charges present around unit length of a wire, unit length of a conductor, a 1 centimeter length sutta ಎಷ್ಟು ಚಾರ್ಜಸ್ ಇರುತ್ತೆ, that is what is called linear charge density, and its SI unit is coulomb meter. Charge unit first ಬರೆದ್ವಿ coulomb, length meter, so here the SI unit is coulomb meter. The next one, students, how does resistivity of a nichrome vary with absolute temperature? ಅವ್ರ ಪ್ರಶ್ನೆ ಏನಂದ್ರೆ, as temperature increases or as temperature decreases, how does the resistivity of a nichrome wire vary? Always remember, resistance or resistivity varies linearly with absolute temperature. Andre, as temperature increases, it may be resistance or resistivity, they also increase in the same manner, proportionately. Therefore, we say, as temperature increases, the resistivity of the nichrome wire also increases. Or the other way, as temperature decreases, resistivity also decreases. And this is very clearly seen in case of conductors. Semiconductors, as temperature increases, resistivity will decrease, resistance will decrease. Nichrome is a conductor. Therefore, as temperature increases, resistivity proportionately increases, or putting in proper terms, resistivity varies linearly for nichrome with absolute temperature. Interesting question. The colored rings marked on a carbon resistor are red, red, red and silver. ಒಂದು ಕಾರ್ಬನ್ ರೆಸಿಸ್ಟರ್ ಇದೆ. ಆನ್ ದಟ್ ಕಾರ್ಬನ್ ರೆಸಿಸ್ಟರ್ ನಿಮ್ಮ ಲ್ಯಾಬ್ಗಳಲ್ಲಿ ನೋಡಿರ್ಬೋದು, ಮೀಟರ್ಗಳ ಮೇಲೆ ಅಥವಾ ರೆಸಿಸ್ಟರ್ ಕಾಯಿಲ್ಗಳ ಮೇಲೆ ಕಲರ್ ಕೋಡಿಂಗ್ಸ್ ಅಂತ ಇರುತ್ತೆ. ಸೊ ಹಿಯರ್ ದ ಕಲರ್ ಕೋಡಿಂಗ್ಸ್ ಆರ್ ರೆಡ್, ರೆಡ್, ರೆಡ್ and silver. I have been asked to give the tolerance of this resistor. Tolerance ಬರಿಬೇಕಾದ್ರೆ ಯಾವ ಬ್ಯಾಂಡ್ ಅನ್ನು ಚೆಕ್ ಮಾಡಬೇಕು? Fourth band. Very simple. What is the fourth band here? Silver. So color coding ಅಲ್ಲಿ ನಾವು ಹೇಳ್ಕೊಟ್ಟಿರ್ತೀವಿ, if it is silver, the tolerance of this resistor is plus or minus 10%. Silver ಬಿಟ್ಟು ಬೇರೆ ಯಾವ ಕಲರ್ಗಳು ಇರಬಹುದು? It may be gold, where the tolerance becomes plus or minus 5%. ಕೆಲವೊಂದ್ಸರಿ the fourth band will be absent. When the fourth band is absent, the tolerance level will be plus or minus 20%. So ನೀವು ಇದನ್ನ ಗಮನಿಸಿಕೊಂಡ್ರೆ ಸಾಕು. Fourth band ಅಲ್ಲಿ ಸಿಲ್ವರ್ ಇದ್ರೆ ಟಾಲರೆನ್ಸ್ ಇಸ್ ಪ್ಲಸ್ ಆರ್ ಮೈನಸ್ 10%. ಫೋರ್ತ್ ಬ್ಯಾಂಡ್ ಅಲ್ಲಿ ಗೋಲ್ಡ್ ಇದ್ರೆ ಪ್ಲಸ್ ಆರ್ ಮೈನಸ್ 5%. fourth band absent, if the fourth band is not coated, if the fourth band is not marked on the resistor, tolerance is plus or minus 20%. Tolerance andre, see for example, if I say a resistor is of 100 ohms, sometimes during soldering, I may lose some resistance or it may be added up. What is the maximum error? ಎಷ್ಟು ಕೊಟ್ಟಿರುವ ರೇಟಿಂಗ್ಗಿಂತ ಆ ಕಡೆ ಈ ಕಡೆ ಆಗ್ಬೋದು ಅನ್ನೋದನ್ನೇ ಟಾಲರೆನ್ಸ್ ಅಂತ ಕರೀತಾರೆ. ನೆಕ್ಸ್ಟ್ ಒನ್, ವಾಟ್ ಈಸ್ ಲಾರೆನ್ಸ್ ಫೋರ್ಸ್? It is the force acting on a charged particle in the presence of a crossed field. Force acting on a charged particle in the presence of a crossed field. ಒಂದು ಚಾರ್ಜ್ಡ್ ಪಾರ್ಟಿಕಲ್ ಮೇಲೆ ಎಕ್ಸರ್ಟ್ ಆಗ್ತಿರುವಂತ ಫೋರ್ಸ್ ಲಾರೆನ್ಸ್ ಫೋರ್ಸ್. ಎಲ್ಲಿ? ಕ್ರಾಸ್ಡ್ ಫೀಲ್ಡ್ ಅಲ್ಲಿ. Now what is this crossed field? If there is both electric and magnetic fields acting perpendicular to each other, that is called as a crossed field. Electric field irutte, magnetic field irutte. These electric and magnetic fields are perpendicular to each other. Then the force exerted on a charged particle in such a region is what we call Lorentz force. Can a neutron experience Lorentz force? No, it is neutrally charged. So, what is Lorentz force? It is the force acting on a charged particle in the presence of a crossed field. Both electric and magnetic fields are perpendicular to each other in such a region. When a charged particle enters such a region, the force acting on it is called Lorentz force. State Gauss law in magnetism. This is a very important question. Either Gauss law of electrostatics or Gauss law of magnetism. Very, very important. It states magnetic flux. Magnetic flux is nothing but magnetic lines of force. Magnetic flux andru onde, magnetic lines of force andru onde. Across a closed surface in vacuum is zero. The magnetic field lines in a closed surface where in vacuum is zero. The magnetic field lines passing through a closed surface is zero because all the lines which enter the surface, all of them will come out. Unlike your Gauss law of electrostatics, here magnetic flux across a closed surface in vacuum is always zero. Electrostatics are enididvi, electric flux across a closed surface is 1 by epsilon naught times the total charges enclosed by the surface. But here the magnetic flux across a closed surface is always zero. Passing on to the next question. Draw the pattern of magnetic field lines for a bar magnet. ಇದನ್ನ ಹಲವೊಂದು ಸತಿ ಪ್ರೀವಿಯಸ್ ಎಕ್ಸಾಮ್ಸ್ ಅಲ್ಲಿ ಕೇಳಿದ್ದಾರೆ. ಪ್ಯಾಟರ್ನ್ ಆಫ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಫಾರ್ ಅ ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್. ಒಂದು ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್ ಸುತ್ತ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಯಾವ ರೀತಿ ಇರುತ್ತೆ, ಯು ಹ್ಯಾವ್ ಟು ಡ್ರಾ ದ ಪ್ಯಾಟರ್ನ್ ಫಾರ್ ದ್ಯಾಟ್. ಸೊ I consider a bar magnet. This is the north pole of the magnet and the south pole. ಓದಿದಿರಲ್ವಾ, ಒಂದು ಮ್ಯಾಗ್ನೆಟ್ ಅಲ್ಲಿ ಎರಡು ಪೋಲ್ಗಳಿರುತ್ತೆ. One is the north pole and the other one is the south pole. So if you draw the pattern, it is somewhere like this. What I want you all to observe is, outside the magnet ಹೊರಗಡೆ, the magnetic field lines will start from north pole and come towards south pole. ಎಲ್ಲಿ? magnet ಹೊರಗಡೆ. But observe inside, it starts from south pole and it moves towards the north pole. This is a very interesting feature when you plot the magnetic field lines for a bar magnet. Outside the magnet, the field lines start from north pole, they come towards the south pole, and inside the magnet, from the south pole to the north pole. Therefore, we say magnetic field lines form continuous loops. ಸ್ವಲ್ಪ ಗಮನಿಸಿ, electric field lines, they do not form continuous loops, but magnetic field lines, they form continuous loops. ಯಾವ ಕಾರಣಕ್ಕೋಸ್ಕರ? Outside the bar magnet, they start from north pole, go towards the south pole. Inside the magnet, they start from south pole and move towards the north pole. That is why they form closed continuous loops. What is wattless current? ಮಕ್ಕಳ, ವ್ಯಾಟ್ ಅನ್ನೋದು ಯಾವ ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟಿ ಇದೆ, SI ಯೂನಿಟ್, ಅದನ್ನು ಗೊತ್ತಾಗಿದ್ರೆ ಡೆಫಿನಿಷನ್ ಗೊತ್ತಿರುತ್ತೆ. ಪವರ್, ವ್ಯಾಟ್ಲೆಸ್, powerless. So the current which will not drive any power, which will not consume any power, consume ಮಾಡೋದು ಅಂದ್ರೆ ಎಳ್ಕೊಳ್ಳೋದು, in a circuit is called wattless current or ideal current. Alternating current chapter ಅಲ್ಲಿ ಓದಿದ್ದೀರಾ, purely resistive AC circuit, purely capacitive AC circuit, purely inductive AC circuit. 5 mark ಅಲ್ಲಿ LCR circuit ಅಂತ ಯಾವಾಗಲೂ ಕೊಡ್ತಾರೆ. So if you observe, if a current flowing in an AC circuit exclusively doesn't draw any current from that, does not pull any current from that, no dissipation of power, such current is called wattless current, ideal current. And you know that can happen only in purely capacitive or inductive AC circuits. ಒಂದು AC circuit ಅಲ್ಲಿ ಫ್ಲೋ ಆಗ್ತಿರೋ ಕರೆಂಟ್ ಯಾವುದೇ ಒಂದು ಪವರ್ ಅನ್ನು ಎಳ್ಕೊಳ್ಳಿಲ್ಲ, ಡ್ರೈವ್ ಮಾಡ್ಕೊಳ್ಳಿಲ್ಲ, ಅದನ್ನೇ ವ್ಯಾಟ್ಲೆಸ್, ಪವರ್ಲೆಸ್ ಕರೆಂಟ್ ಅಂತ ಕರಿತೀವಿ. ಮತ್ತೆ ಯಾವ ಸರ್ಕ್ಯೂಟ್ ಅಲ್ಲಿ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗುತ್ತೆ, ಅದು ಪ್ಯೂರ್ಲಿ ಕೆಪಾಸಿಟಿವ್ ಆಗಿರಬೇಕು ಅಥವಾ ಪ್ಯೂರ್ಲಿ ಇಂಡಕ್ಟಿವ್ ಆಗಿರಬೇಕು. The next one, mention the angle between electric field and magnetic field in an electromagnetic wave. ಏನು ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ವೇವ್ ಅಂದ್ರೆ ನೋಡಿ ಆ ಪದದಲ್ಲೇ, ಎಲೆಕ್ಟ್ರಿಕ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ವೇವ್. ಇಟ್ ಈಸ್ ಅ ವೇವ್ ವೇರ್ ದಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಅಂಡ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ಸ್ ವೈಬ್ರೇಟ್ ಮ್ಯೂಚುವಲಿ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಟು ಈಚ್ ಅದರ್. ಡೆಫಿನಿಷನ್ ಹೇಳಿರ್ತೀವಿ, ಯಾವುದೇ ಒಂದು ವೇವ್ ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡು ಇದ್ದು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡು ಇದ್ದು ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಗಿ ವೈಬ್ರೇಟ್ ಆಗುತ್ತೆ, ಅದನ್ನೇ ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ವೇವ್ ಅಂತ ಕರಿತೀವಿ. ಲೈಟ್ ಈಸ್ ಅನ್ ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ವೇವ್. ಸೊ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಅಂದ ತಕ್ಷಣ ವಾಟ್ ಶುಡ್ ಬಿ ದಿ ಆಂಗಲ್? 90 degrees. Name the electromagnetic wave which keeps the earth warm by greenhouse effect. ಇದನ್ನೇ ನಾನು ಹೇಳಿದೆ ಶುರುನಲ್ಲಿ. Especially when it comes to 1 markers or 2 markers from the chapter electromagnetic waves, 7 type of electromagnetic radiations we specified. You should know the applications. Here there is no logics. It is just remembering. So greenhouse effect. Which radiations are used to keep the plants warm? It is infrared waves. ಅದೇ ರೀತಿ ಅಲ್ಟ್ರಾವೈಲೆಟ್ ರೇಸ್ ಮೇಲೆ ಪ್ರಶ್ನೆ ಬರ್ಬೋದು, ರೇಡಿಯೋ ವೇವ್ಸ್ ಮೇಲೆ ಬರ್ಬೋದು, ವಿಸಿಬಲ್ ಲೈಟ್ ಮೇಲೆ ಬರ್ಬೋದು. ಸೊ ಯು ನೀಡ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದ ಅಪ್ಲಿಕೇಶನ್ ಆಫ್ ಈಚ್ ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ರೇಡಿಯೇಷನ್. Write the condition for diffraction maxima in terms of wavelength of light and slit. Diffraction maxima ge condition kelidare. This is generally or the condition for minima, but when it comes to maxima, it is a sin theta is 2n plus 1 lambda by 2. So lambda is the wavelength of light used. ಅದೇ ರೀತಿ ನಮಗೆ ಕನ್ಸ್ಟ್ರಕ್ಟಿವ್ ಡಿಸ್ಟ್ರಕ್ಟಿವ್ ಇಂಟರ್ಫರೆನ್ಸ್ ಅಲ್ಲಿ yes, you may get questions for path difference or phase difference. See, this is what I told. Applicative conditions ಗೊತ್ತಿರಬೇಕು. How does the resolving power of a telescope, microscope alla, telescope, change on decreasing the aperture of its objective lens? Yes, resolving power is directly proportional to the diameter of the aperture. Diameter ಜಾಸ್ತಿ ಆದರೆ resolving power ಜಾಸ್ತಿ ಆಗುತ್ತೆ. Diameter of the aperture of the lens decreases, resolving power decreases. So it is directly proportional to the diameter of the objective. The next question, define impact parameter. Impact parameters is, suppose I have an atom. I'll call the center of the atom as the nuclei. Atom center alli enirutte? Nucleus. I have a trajectory of alpha particles which is approaching the nucleus. Okay? It is the trajectory of the alpha particles which is nearing to the nuclei. Some particles may suffer collision, some pass straight. You have seen Geiger-Marden's observations. Now, the perpendicular distance, impact parameter is some distance, perpendicular distance from the center, considering to the initial direction of the alpha particles, is what you call impact parameter. Initially one directional barta irutte, alpha trajectory, alpha particles. Some of them may pass straight, some may get deviated by an angle of 90 degrees, some strike the nucleus, return back by 180 degrees, backscattering and karitive. So impact parameter is the perpendicular distance. From where? From the center, considering the initial direction of projection. That is what is called impact parameter. Going forward, students, the 14th question, in which type of extrinsic semiconductor holes are minority charge carriers? ಗಮನಿಸಿ, majority ಕೇಳಿಲ್ಲ, You have to thoroughly go through the question. Minority, two types of semiconductors, P-type, N-type. P-type majority ಯಾವುದು? Holes. N-type majority ಯಾವುದು? Electrons. So where holes become minority? It is in N-type extrinsic semiconductor. So N-type majority charge carriers are electrons. Minority charge carriers are holes. So reflecting the question always becomes important. Very simple. Circuit diagram for PN junction diode. Very simple. The base of the diode is always positive. The nozzle is always negative. P-type, N-type. As I discussed previous, PN junction diode. P-type, holes positive. N-types, electrons negative. So my dear students, in this session, I have seen that you can answer all 15 questions very easily without knob or notch. Direct, 1 mark, 1 statement. We will not go for essay type where it comes for 1 mark, and out of 15, you would have to answer only 10. The next session, I'll come up with the 2 markers and 3 markers. Until then, I expect, go through this. Yes, make the best use. Thank you.